Welcome my dear friends, this is again your Virat Kumar, lecturer in electrical and electronics engineering. Yesterday we have discussed about projection of planes. I think it's part 2. So we have seen some problems. So there are of about total 11 problems we have seen. In the first session we have seen about 4 problems, and in the last session, in the next session, that means yesterday, we have seen the rest of the problems. So I hope you have got all the points in it, and I hope you are practicing well. Okay, if you want, you can see my video in the YouTube channel by typing the name Projection of Planes Part 2 by K. Virat Kumar. Okay, I again welcome you all. Today we will see about the determination of true shape of plane figure when its projections are given. So by using auxiliary plane method. So it says to determine true shape of the plane figure when its projections are given by using auxiliary plane method. So what will be the problem is description of final front view and top view will be given. You are supposed to determine true shape of that plane figure. So there are some following steps to be followed. So these are the follow the below given steps. It's number 1 is draw the given front view and top view as per the given information in problem. And second, then among all lines of front view and top view, select a line showing true length. Its other view must be parallel to xy axis line. And the third one is draw x1 y1 perpendicular to this line showing true length. Fourth one is project view on x1 y1, it must be a line view. And fifth one is draw x2 y2 parallel to this line in view of parallel to this line view and project new view on it. So it will be the required answer, therefore the true shape. So these are the 5 steps to be followed. Is it clear? Okay, then the facts you must know is, if you carefully study and observe the solutions of all previous problems, you will find if one view is a line, if one view is a line view and that too parallel to xy line, then its other view will show you the true shape. So now final views are always some shape, not line views. So applying above method, we first convert one view in inclined line view by using x1 y1 auxiliary plane, then by making it parallel to x2 y2 we get the true shape. So there are some study next 4 cases will be seen from the next slide. So here he directly stepped into the problems. The first problem is top view is a triangle ABC. AB is 50 mm long, angle CAB is 300 and angle CBA is 650. No, angle CAB is 30 degrees and angle CBA is 65 degrees. So here degrees may not be mentioned, so 30 degrees and 65 degrees. Okay, then A dash, B dash, C dash is a front view, and A dash is 25 mm, B dash is 40 mm and C dash is 10 mm above HP respectively. And draw the projections of that figure and find its true shape. So there is some triangle. There are some minimum procedures to be drawn or to make the diagram. So as per the procedure, first draw front view and top view as per the data. So the given triangle, we need to first make the triangle. First draw the front view and top view as per the given data. Then in top view, line AB is parallel to XY, hence its other view A dash B dash is true length. So draw x1 y1 perpendicular to 8, perpendicular to 8. The next point is project view on x dash y dash. In that, first draw the projections of A dash B dash and C dash on x1 y1. Then from xy take distances of A, B and C. In top view, mark on these projectors from x1 y1, name points A1, B1 and C1. And C is, this line view is an auxiliary top view. So draw x2 y2 parallel to this line view and project auxiliary front view on it. For that, from x1 y1 take distance of A, B, nothing but A dash, B dash and C dash, and mark from x2 y2 is equals to on new projectors. So finally name points A1 dash, B1 dash, C1 dash and join them. This will be the required true shape. So this is the procedure for making it. So you may not be able to understand by reading all these procedures. When we'll just make the diagram, you will be able to understand. So firstly, the xy axis line and a triangle. And the triangle, as I have said you, AB is 50 mm long, and from A the angle is 30 degrees and that is 65 degrees. Now project. It looks like a he said that the point A is, we'll see, the point C is 10 mm above the xy axis line C dash, and the A dash is 25 mm above, so that 15 plus 10 is 25 and it's again 15. So this is here required diagram. Now for the AB, which is true length, since the length is given 50 mm, that is the true length, so take a projection line from that and a perpendicular line, it should be 90 degrees, and then mark it as x1 y1. Previously it was x and y, now it is x1 and y1. We have took the projections. Now the projections actually a parallel line to that. Now this will be your x2 y2. Now we have all the points. So a1, this is your a1, that is your b1, this is your c. So this will be your true shape. So always for new front view, this will be a true shape. Always for new front view, take distances of previous front view, and for new top view, distances of previous top view. So remember this thing, and please make a note of this by taking a minute. Just make the diagram clearly and neatly. Okay, we'll move on to the next problem. Similarly, front view and top view of a triangle plates are shown. Determine its true shape. See, use same procedure steps of previous problem, but there is only one difficulty in it. No line is parallel to xy in any view. That means no true length is available. In such cases, draw one line parallel to xy in any view, and its other view can be considered as true length for the purpose. So here a dash 1 dash line is front view is drawn parallel to xy, hence its top view a to 1 becomes true length. So then follow same steps and determine true shape. So these are some study the illustrations. See the same figure. No, this is a question where the front view and top view of a triangle plates are shown, already given. This is the front view, this is the front view, and this is the top view. Now for the true length, make a 90 degrees line. So this is your required true shape. So always for new front view, take distance of previous front view, and for new top view, distance of previous top view. So that you need to remember. Is it clear? So make a note of this. Okay, is it finished? So shall we move on to the next? Okay, please note the question. Okay, so what's the question given? There's a front view and top view, both are circles of 50 mm dia. Determine true shape of an elliptical plate. Is it clear? There's a front view and top view, both are circles of 50 mm diameter. Determine true shape of the elliptical plate. So adopt the same procedure. AC is considered as line parallel to xy, then A dash C dash becomes true length for the purpose. So using steps properly, true shape can be easily determined. So by studying the illustration, we can analyze that front view and top view both are the circles of 50 mm diameter. So this is the front view and this will be your top view. So both are of same diameter. So by this we need to determine the true shape of an elliptical plate. Now here just remove this FV. We took parallel line and projecting to A1, B1, C1 and D1. How these points are actually drawn is from the xy axis line. See the distance of this from xy axis line to D. So similarly from the x1 y1 axis line to D1. Similarly from here to A1. So here to A1. Similarly from here to B1. So here to B1. Similar from here to C. So that will be here to C. So both A and C lies on same point. So in that way we have obtained the points. Now for this, again a parallel line of x2, y2, we need to take the projections, and now again mark the points. Similarly for A, now from this AC, DN, D, the distance. Now joining all these points smoothly, we will obtain a ellipse which is the true shape. So now always for new front view, take distance of previous front view, and for new top view, distance of previous top view. So it's clear. So this is your front view and this is your top view. So what is saying, always for new front view, take distance of previous front view, and for new top view, take distance of previous top view. Just remember that. Okay, make the question, make the answer, take a couple of minutes. Okay, we'll move on to the next question. Note down the question. The question is, draw a regular pentagon of 30 mm side with one side 30 degrees inclined to xy, and this figure is top view of some plane whose front view is a line 45 degrees inclined to xy, and determine its true shape. So in this case also true length is not available in any view, but actually we do not require true length to find its true shape, as one view, front view, is already a line view. So just by drawing x1 y1 parallel to this view, we can project view on it and get true shape. Study the illustration. See here, there is an xy axis line. By 30 degrees of line, we are drawing a pentagon of 30 mm side. and mentioning the points A, B, C, D and E by taking the projections from this and by a 45 degrees line we are marking all the required points. So this is a front view, the figure. So this will be a front view and this will be your top view. So front view of a plane obviously looks like a line by the constraints he just given about a 45 degrees of angle, but there is no true shape is obtained in this. So for this we need to draw a parallel line for this, which is x1 y1, make the projections from that and mark the points of all A, B, C, D and D. A, B, E, D, C. By joining all these points we will get the true shape. So always for new front view take distance of previous front view, and for new top view take distance of previous top view. So all this from this axis line from here to this distance is from here to here, and axis to E, see axis to E, axis to B, see axis to B, axis to C, see axis to C, axis to D and axis to D. In that way we are marking the points and joining all the points we will obtain the true shape. Okay, we'll move on to the next slide. So I hope all the things have been completed in the planes. Now there is a topic of solids. So the part of planes is entirely completed. So in this we'll see about the light introduction of solids, and for tomorrow we'll see about the problems and illustrations all in the next session. So firstly, solids. To understand and remember various solids in this subject properly, those are classified and arranged into two major groups. Group A, solids have top and base of same shape, and group B, solids have base of some shape and just a point as a top called apex. Nothing but the cone. This group A may looks like a cylinder and group B like a cone if for a circular figure. So simply these are called pyramids and these are called prisms. So simply these are prism, what happened? Okay, this. So simply these are called prism and these are called pyramid. Okay. See, for a cylinder it looks like this. That's the prisms. It's a triangular prism, square prism, pentagonal prism, hexagonal prism. See, you have triangular, square, pentagonal, hexagonal. The above one is cylinder. And for cube, a solid having 6 square faces is called cube. So for this, a circular one is called a cone, which called pyramids. This is a triangular prism, pyramid, square pyramid, where the Egypt pyramids looks like, pentagonal pyramid, hexagonal pyramid. See, triangular, square, pentagonal and hexagonal. And for this, tetrahedron, a solid having 4 triangular faces. So square prism, square pyramid may also be called as tetrahedron, a solid having 4 triangular faces. So is it clear? Just make a note of this, or else we'll see it again, or else we'll move on to the next. So solids, dimensional parameters of different solids: square prism, square pyramid, cylinder, cone. See, as we have seen in the previous slide, square prism looks in this way, square pyramid in this way, cylinder in this, and cone in this way. Now here it's a top, that's a rectangle face, it's a longer edge, it's a corner of base. We'll see some dimensional parameters of different solids, how and after this in further we will need to calculate some problematics. So the language used in the problems in this way, that the rectangular face, longer edge, corner of base, the top. So in order to remember or analyze, so we are just dimensional parameters of different solids, nothing but the solids language. This will be the edge of base, that's the corner of the base, this is your edge of base, that will be your base. So is it clear? We'll see it again. See, that will be your top, it's a rectangular face, this is your longer edge, that is your corner of base, this is your edge of base, that is your base. Similarly in square pyramid, that's the apex or tip of the figure, top of the tip of the figure, that is your slant edge, it's your base, edge of base, corner of base. Is it clear? That's your triangular face. Is it clear? I will see it again. Apex, slant edge, base, edge of base, corner of base, triangular face. Now coming to cylinder cone, all these are of these are generators, nothing but the imaginary lines generating curved surface of cylinder and cone. That will be your base, that's apex, base. So this is the thing in cylinder and cone. Now these are some cutting planes, cutting solids, nothing but section of solids, top and base not parallel, top and base are not parallel. So what to be done? These are some sections of solids where the top and base is parallel, nothing but are called frustums of cone and pyramids, where the top and base parallel to each other. So here these are cut inclined, so these are cut in parallel. Now see some examples. While observing front view, XY line representation horizontal plane standing on HP on its base, so the axis perpendicular to HP and parallel to VP. This will be a front view, and this is resting on HP on one point of base circle, on one point of base circle. So axis inclined to HP and parallel to VP. Now this is lying on HP on one generator, so axis inclined to HP and parallel to VP. While observing top view, XY lines represent vertical planes standing on VP on its base. So here the axis perpendicular to VP and parallel to HP. Here resting on VP on one point of base circle. So axis inclined to VP and parallel to HP. This is lying on VP on one generator, so the axis inclined to VP but parallel to HP. So basically make a note of all these things. These are some considerations. Okay, we'll move on to the next slide. So here you can see so there are some steps to solve problems in solids. The problem is solved in 3 steps. So step 1, step 2 and step 3. Step 1, assume solid standing on the plane with which it is making inclination, and if it is inclined to HP, assume it standing on HP. If it is inclined to VP, assume it standing on VP. If standing on HP, its top view will be true shape of its base or top. If standing on VP, its front view will be true shape of its base or top. So begin with this view. Its other view will be a rectangle if solid is cylinder or one of the prisms. Its other view will be a triangle if solid is cone or one of the pyramids. So now draw front view and top view of that solid in standing position. Step 2, considering solid inclination axis position, nothing but draw its front view and top view. Step 3, in last step, considering remaining inclinations, draw its final front view and top view. So these are some 3 steps to be solved, 3 steps to solve problems in solids. The general pattern of these 3 steps of solids, looks in this order. First, group P solid cone, group P solid cone. See, this will be your first step, second step, and this will be your third step. So this is a normal thing where the front view and top view, and this will be your inclination. So this is inclined to HP. Just observe the figures. This is inclined to VP, so the diagram is inclined to both the planes. So in group A solid, it's a cylinder. It's a normal, so inclined to HP, inclined to VP. So this is an orthographic view where we can see all the 3 dimensions: front view, top view and side view. Similar for group B solid cone. Now here in this case, solid is inclined to HP, solid is inclined to HP. Here the solid is inclined to VP in these 2 cases. See, circle comes just the reverse. This comes above and this comes below. See, you can see it the same way. Okay, is it clear? So just observe, there are next slides of study of next 12 problems and practice them separately. So we'll need to practice them separately. So there are some 12 problems. So for today it's finished for this session. So tomorrow we will start the actual problems involved in the solids. So thank you one and all. Have a nice day.